morning. So I am going to just cover what we went through most of this week. So the last thing that you should have is the revision of quadrilaterals. Okay, so that is basically all the quads. You've got the, hold on, you see properly. Okay, so then you've got that. So you've got the rectangle, the square, we have the kite, which is over there, and we also went through different triangles as well. So we've got the equilateral, the isosceles, scalene, and right-angled triangle. So yeah, so basically that's most of what we covered. The rhombus and the parallelogram and the trapezium, just so that you know what is the difference between all of them. Your notes might look different to this, but it's pretty much the same thing. And just for in case you need to know, over here, if we have to have a construction of a rectangle, I showed the class what you would be marked on. So basically the construction lines, correct construction lines, the length of the side, the right angles, the connection of the line, and then labeling it AB probably as well, and then the same for the rectangle on the other side. Anyway, so that's pretty much what was covered last time, and then we went on to similar and congruent shapes. So what I want you to do on your book, you will have a page like this. All you must do is just split it in half for me. So you've got similar on the one side, and then you've got, put on the date first, so maybe put the date on top, and then you've got similar over there, and then you've got congruent over there. So I'm going to give you the notes for it. So it's split in half. Okay, and then we've got similar triangles. That is when we have triangles that are exactly the same, literally exactly the same, but the one thing that changes is that you've either got a smaller triangle and a bigger triangle, or a bigger triangle and a smaller triangle. So it's just like they've enlarged it or they've made it smaller. Okay, so that's something that you need to have down. So the one thing that I need you to write is similar. So all the similar triangles, they have the exact same angle. So if you can look here, you've got 80 and 80, 30 and 30, and 70 and 70. The angles are exactly the same, but the sizes on the sides. So that's 3, that's 4, that's 5. This is now going to be 12, 16, and 20. So you can see that they actually were enlarged by a certain amount. So it is in proportion to each other. So if I have to look from 3 to get to 12, I times by 4. From 4 to get to 16, I times by 4. From 5 to get to 20, I times by 4. Okay. So what I suggest you do is you write this down. So you can actually pause the video if you want to, and then you write that down under similar. So the sizes are different, so but it has to be in proportion to each other. And then it's just showing you the main differences there. Then the symbol for similarity is 3 lines going vertically. So it's 1, 2, 3, and they're going down. Alright, how I like to remember it is it kind of looks like a dollar sign. Okay, so then it goes down. That is for similar. Then you've always got reasons for why something is that way. Okay, so that is angle, 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 which is your reason over there. That is the reason, the only reason for something to be similar to each other. Alright, so when you're busy proving it, you have to have that. I'll show you an example later. Okay, then we move on to congruency. So if you don't have that in, your page should have that part on the one side of your page. And then you've got congruency. So congruent, I like to think of it as a little bit of a European euro sign or whatever. So you've got all the lines going that way. Congruent is when the shape is exactly the same. All they've done is they've just turned it and they've moved it around. So the one thing that I want you to really write down, let me just see if I can cover this quickly. Okay, the one thing that I really want you to write down over here is that, so it is exactly the same, which means all the sides are the same, all the angles are exactly the same. The shape has just been turned, or otherwise inverted is kind of like if you have to think of a mirror reflection, it's kind of that kind of thing. So inverted is kind of like when it's been turned inside out. Okay, so if you look, I took this shape and I literally just spinned it on the 70 side, so it just went and it turned that way. Okay, so yeah, so I turned it, and you can see all the things are exactly the same. So what I did is in class I gave them this triangle, and then I put the 70 there, the 30 there, and the 80 there, and then I asked them where did I put all these sides. So if I look between the 30 and the 70, I've got a 4. So I look 30 and 70, there's a 4. I need to put a 4 there. Between the 30 and the 80, there's a 3. I need to put the side of 3 between 30 and 80, and then the last one would be 5. Okay, so that's like an easy thing, just for you guys to get into the habit of it. So what I suggest is you pause and you write this down for me, please. So congruency, remember it's C for congruent, but the symbol for it that you use when you're proving is the 3 lines going that way. Okay, then the one thing that I need you to write down now, if you haven't got it down already, is the reasons. So remember, for the other one, for similarity, we only had 1 reason. Now for congruency, we've got 4. We've got 4, but the main 3 I need you to remember. The 4th one I'm not really going to ask now, but you will be asked in high school. Okay, so you can't have 3 angles the same. Why? Because that represents similarity. I hope you said that. Anyways, alright, so the first reason is side, side, side. So all the sides are the same. Okay, so if you prove that this side is the same length as that side, and that side's the same length as that side, the same length as that side, then it means that it is congruent to each other. Side angle side, that means that the angle is between the 2 sides. So if I've got 5, 70 degrees, and 4, there's a side, an angle, and a side. Okay, the same thing here. I've got 5, 70 degrees, and 4. So I need to have that whole thing there that matches with that. And that's the side, angle, side part. Then I've got angle, angle, side. So that would be 2 angles and a side. So angle, angle, and a side. Then I'm going to look for the same thing again. So 30 and 80. So I've got 30, 80, and then 5. Okay. And then the last one is right angle, hypotenuse, side. So that, remember I told you guys hypotenuse is representing, in a right angle triangle, it's always representing the longest line. You don't really need to know that yet. That's more for grade 8. But it's just that you can know what. And it only works with a right angle triangle. So they will always have a right angle in there, and your hypotenuse is the longest line, so it's opposite the right angle. You don't need to really know that for grade 7, but I'm just telling you for when you get to high school. And then a side, so it can be any one of these sides. Alright, but the main 3 that we're going to focus on is these 3 here. But you also need to know that for in case when you get to high school, so that you know that there are 4 reasons that you have to keep in mind. Please write that down underneath, so not next to, underneath this that you've written down. Alright, so you can pause this and then you can write it down. Otherwise, I'm going to move on. So that is what you need to have in your books. So the second thing that I need you guys to do, so you can either do it underneath the similarity and the congruency part in your book, but I suggest you rather write it down on a clean page. These are the actual examples of what I would give you, or what you will be getting. So they will give you what I've given you here. So let me see if I can just show you. I just want to show you the top part. Hold on, I've got an idea. Hold on. Okay, so you're going to write this in your book, so don't stress about it. Here we go. Okay, let's see if I can do this quickly. Hey, there we go. Okay, cool. So we've got our shape that I'm going to give you, and we're going to say to you, prove that triangle ABC, so ABC, I don't know my mouse, but it's the top part here, so it's A, B, and C. That small triangle is similar. So similar, what is the only reason for something to be similar? You should know that is triple A. So that is angle, angle, angle. So you need to prove that all the angles are exactly the same in order for it to be similar. Okay, so we've got ABC, and then we've got the bigger triangle, which is ADE. Okay, so is always our statement. You should know that. Okay, so our statement is in triangle. So we're literally just telling them what we're doing. So we're talking about the triangle. So in triangle ABC and triangle ADE. That's our statement. Finished in class. It's already 1 mark. Okay. We're going to find the reasons why the angles are equal to each other. So we've got this angle 45 degrees at B in the small triangle, and this angle D in the big triangle is 45 as well. So we're then going to say angle ABC is equal to, remember B is the angle, so we put a hat on that angle over there. Okay, and the same thing here, we've got angle ADE, and the hat on D because that's the angle, and they are both equal to 45 degrees. The reason is given because they told it to us, right? The same thing with the next step. It's also pretty easy. So rather do all the things that they've given you straight away, because then you don't have to really look for much else. Alright, then you C over here is 60, and that's also 60. So let's then write that down. So we've got BCA, so BCA with the hat on the C because that's where the angle is, equals DEA, and that is 60 degrees. They are both 60 degrees. The reason is given because they told us. Then the last one, a little bit tricky. So because you've got the two bottom angles of the triangle, what's the only angle that they still need to give you? The top one. Okay, do you see share this? So it's a small triangle at the top. That small triangle goes up and it's meet the same thing here. They both meet at A. Okay, so A would then be, angle A would then be called common because they both share that. There. So we've got the three angles, cool. But now we just need to kind of like write a conclusion. It's almost like an essay. Okay, so the end part is we have got, therefore, triangle ABC, AC, is similar, the 3 lines down that I told you about earlier, triangle ADE. And the reason why they are similar is because we've put here, we've got 1, 2, 3 angles, angle, 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 and that is why we have angle as our answer. Alright, so that's the similarity one. As much as I will probably give you. If anything, I will give you that. Otherwise, I'll actually give you simpler questions than that. Right. Alrighty. So then they're going to give to you in this one. This is now congruency. So they've got this parallelogram, or this, actually it's not a parallelogram, this quadrilateral, it's got 4 sides, but it can't be a parallelogram, so just check why, because that's 5 and that's 5, so it can't actually be a parallelogram. Okay, so it could be a rhombus. Okay, why am I not saying that it's a square? So you should have then said, because 30 plus 30 does not give me 90, it has to be 90 degrees in order for it to be a square. Okay, so it's actually at 60 degrees in the corner here. So, but all the sides are the same length, so that means then that this is a rhombus. Okay, So it says, prove that triangle ABD, so this small triangle here, prove that the triangle is exactly the same or congruent to triangle CBD. Okay, so what they did is they basically took this triangle, so they did that, and they flipped it over. Okay, what happened. And then the one thing that I told you that you have to do is you always have to write your statement. Okay, I hope you have been writing this down in your book. Alright, so it's CBD and triangle CBD. Did I write that down? Yeah, okay, I did. I got a bit worried there. So, what's going to happen now is you've got your statement. I don't think I'll find it again. It's pretty simple. Because it's the same as what happened in the similar triangles. If you need me to explain, it's cool, I will. You must just let me know. So we've got the things that they've given us. So you can see that they are both 5 centimeters. Alright? So what we're going to do is we're going to say that AB is equal, so AB is equal to BC. BC. Okay? And they are both 5 centimeters in length. Okay, the reason why is because it's been given to us. They told us it was 5 centimeters. Okay, and that's a side, right? It's a length. It's not an angle, it's a side. And then the other thing that they gave us, which is pretty obvious, is that's 30 and 30. So, what we're going to do is we're going to say that A, B, the angles at B, and D, so A, B, D, angle is 30. And the other one that's 30 as well, CBD, also 30 degrees. So we're then going to write that down. So we've got ABD equals to CBD, which is 30 degrees. Reason, they gave it to us, so it is given. Now the last thing is very similar to what we did in the similarity one. It's something that they both share. Something they're both sharing over here. This triangle here and that triangle there. What do they both share? And you should see over there. There's a what they both that is common to both of them. So they are both sharing the line BD. So then what we're going to write is BD is common. So now do you see we've got a side? We've got a side here. Then we've got an angle, and then we've got a side. So the same thing here. Side, angle, and side. So what will our reason be why they are similar? Side, angle, side. I mean not similar, congruent. Alright, so then we're going to write our conclusion. Therefore, triangle ABD is congruent, so the 3 lines going horizontally. Triangle CBD, and the reason is side, angle, side. The angle has to be in the middle between both of them, otherwise your answer is wrong. Okay, so that is pretty much it. Something that I also want to just mention to you, because I mentioned it to the other kids, especially I might try and trick you as well. They'll give you something like this. So it will look like a rhombus. If you see, it looks kind of like a rhombus because it's a little bit tilted and it's got all 4 sides the same length. Alright? But sometimes what they will do is it looks like a rhombus, but it's not, because that is a 90 degree. So then it's actually a square. Okay, so something that you need to just keep in mind. So that it will give you something that will look completely different to what they're actually asking you. So sometimes they'll give you parallel lines that look very skew, and then they'll put arrows on it, and then you need to tell them that it's parallel to each other. Also, something else that I need to just remind you of, remember similarity, the bigger and the smaller shape, it doesn't always work with triangles, eh? It also works with squares and rectangles and circles and all those kinds of things, so just keep that in mind. And then congruency is just when you have the same shape and it's just been turned or flipped or inverted or whatever, that kind of thing. And always remember, perpendicular lines, parallel lines. Perpendicular is when it is one line running through the other one at 90 degrees, and the other one is parallel lines. Parallel lines are technically when the lines are at the same angle to each other. So this would be at 90 degrees and this will be at 90 degrees. So that means that they are perpendicular and parallel to each other. If this is 60 and that is 60 degrees, they are running parallel to each other because they're running at 60 degrees at the same time. Anyways, there's a bit of a technicality there so that you can at least just understand it a bit more. But basically, parallel lines are when they're running at the same distance and length to each other. But yeah, you'll learn a bit more about it in high school, why it is that. So hopefully that will be a bit helpful for you. And then there's just one more video that I'm going to tell you about, but it is actually more about revision that we did on Friday. So I will just I'll see what I can do to show you about that. So yeah. Otherwise, let me see if I can. I don't know if I can actually show you on my screen. So let me see if I can do it. If not, then I will have to just type it up for you. So maybe. Hey, okay, cool. So let's see if I can record me going onto Google. Seems like I can. Alright, so I went into Siavula and I got practice tests, and I basically let the kids write down, or your classmates write down exactly what I did. So I don't know if you're seeing everything that I did. So I showed them, if you don't know how to use a protractor, it tells you how to use a protractor there. It tells you about all these different straight lines and shapes and perpendicular and parallel, all that kind of stuff, just so that you can see what it's like as well. Let's see. Let's go there. I don't want to have to sign up so that I can show it to you. Here's another example of what you've got. Perpendicular. You've got congruent. So it shows you what congruency is. So like those would be actually no, they're not. Anyways, things like that. Okay. So I went into this one. Hopefully it's not going to ask me to sign in. Cool. And then I went right down to the bottom. I did this with them. Let's see. Yeah. Okay, I think so. We started it here. Geometry lines. So this is what we did on Friday. So basically it was just revision of whatever we've done. So then I asked them to draw these questions for you. So I'll ask you to actually write down and draw the questions, so that you have it in your book. Actually can't remember what the heading was. I think it was revision questions or something. So yeah, I'll give you the questions that I did with them, and then you must just do them for me. So this is the geometry of straight lines. We did number 1, where they drew the grid, because you actually have to answer on the grid. So draw the grid for me. So what I told them is, you've got your blue lines that go in between your page. So I said put a dot between the blue lines, and then that's what I did. So they wrote down the questions, draw on the grid the line segment through R, so that's going to become perpendicular. So it's going to go through here. So you then label it. I think it's TU, hey? Yeah, so you label it TU. So you can put a T on the top dot there, top left dot, and then you go right down through R to there, and then you can label that U. And then you put a 90 degrees here where it combines, because they said to you that it is perpendicular to PS. Okay, so then it says draw on the grid line that it is parallel to PS. Draw a line that is parallel to PS. So basically you can draw it wherever you want to, and it's called WU. So you can put a line there, and you can say WU, and then put the parallel lines in, or the parallel arrows in, to show you that it's parallel to each other. It can be at the bottom, it can be at the top, so it can even be this line here, wherever you want to put it. Oh no, it's WX, sorry. Okay, then yeah, I didn't do that one. We didn't do that one either. Didn't do that one. And then construction of geometric figures. Yeah, we did this one. Yeah. So then we did this question here, which I said was number 2. So they drew this for me, and then you have to say the angle name. So the size of the angle, you can actually guess it for me if you want to, or you can actually measure it. I suggest maybe trying to use your protractor to measure it so that you can see if you know how to do it. And then the classification would be angle B. So this angle here is B because there's only one B, or only one angle at B. So that one looks like it's smaller than 90, so it would be an acute number. So I would say that's maybe like 45 or 50, and then the classification would be acute. The one thing, I think it's this one, CDB. Yeah, so CDB. Do you see it's the whole of D? So the whole of D is actually called what? If this is a whole line here, it's called a straight line. Okay, hopefully you said that. So it's called a straight line. So you don't actually need to measure that. It should be 180 degrees. Okay, so that would be called a straight line. And then reflex, CAB. So CAB, but it's a reflex, so it goes all the way around. It means that your angles, I would suggest you actually measure it for me so that you can see how to measure a reflex angle. So that should be 180 plus maybe, I don't know, maybe 30 plus 30 degrees or something. I don't know. Figure that out for me, and that would be called a reflex angle. It has to be more than 180 degrees. Okay, and then the last one that they did here in this section was construct a semicircle with a radius of 3 centimeters. Okay, so that one is basically just, remember it's a semicircle, it's not a full circle, it's half a circle, and then the radius of 3 centimeters. Not doing that one, didn't do that one. And then I told them to write down geometry of shapes. So the other one was construction, this one is actually the geometry of shapes. And then we did the definitions. Okay, so the name of the shape that fits the description, a 3-sided shape that is exactly 2 sides equal in length. By the way, if you guys can't see any of this, then I will just tell you where to find it. A 3-sided shape, so that's a triangle, that has exactly 2 sides equal in length. That would be called an isosceles triangle. I hope you got that. Okay, so then we've got 1.2. A 4-sided shape, so that's a quadrilateral. This is a bit different. With both pairs of opposite sides parallel and equal in length. Okay. With no right angle. So it doesn't have a right angle, so it can't be a square, it can't be a rectangle. But it says opposite sides and parallel, opposite sides parallel and equal. So that means that we've got the opposite sides of the actual shape is equal. So it doesn't mean that the whole thing is the same length. And it means that opposite sides are parallel, because you can't have everything that is parallel to each other in a 4-sided shape anyways. It has to be the length, or the lines of the shapes have to be different. It can't be all parallel. They can't all be running the same way in order to create a shape. So it's actually called a parallelogram. Yeah, a parallelogram, okay? Because otherwise it would have been called a rectangle. But because it said no right angles, that means that it is called a parallelogram. Okay, 1.3, a 4-sided shape, quadrilateral, with only one pair of opposite sides parallel. That is called a trapezium. I hope you got that. It's called a trapezium. Okay. Number 2. What is, so that we did that one, and then this one. What is the correct term for each of the following parts of the circle with center B as shown alongside? So basically I gave them this, and then I also gave them extra questions for this question. Please make sure that your answers are maybe done in color or something like that. I will actually see if I can get an image of these questions so that you can actually get this on Monday. Hopefully I can get this on Monday. So yeah, it's basically write the questions. So what I told my children to do is write the question, and then you write the answer in color, or otherwise underline the question and then write the answer next to it in the same blue pen. Okay, so the first thing that I asked, what is line AB? Line AB is called a radius, and then I extended this line, so we've got from there to there, and then I extended it to the end of the circle. So when a line goes through the center of the circle, that is called, from one side to the other, that is called a diameter. I actually figured out on Friday I've been telling you that wrong. That's called a sector. It is called a segment. It is called a sector. This part here is called a sector. Okay, when you have a chord, a line that goes from the outside of the circle to another part of the circle, but it doesn't go through the middle and it doesn't go through the center, that is called a chord. And the part between the chord, so if the chord goes here, the part between the chord and the end of the circle and the arc of the circle here is called a segment. Okay, and remember, instead of calling this a curve, it's actually called an arc. Okay, so this is called an arc here, where it makes it part of like a half of a circle-ish thing. Okay, and then the last thing that I want to tell you about the circle, and the outside of the circle is called the circumference. Okay, so it's not called perimeter. Perimeter is used for all the other shapes, but because it's a circle, it is called circumference. Okay, and then the third question that I did was this one. Yeah. So Daryl says, four-sided shapes I am thinking of that have at least one pair of adjacent sides equal. So, okay, I read that. Wait, hold on. The four-sided shapes I'm thinking of have at least one pair of adjacent sides equal. What are they? So if you don't know what adjacent sides means, adjacent just means next to. Okay, so they're like sitting next to each other, they're chilling. So you've got the two sides that are next to each other that are equal, and they're sitting next to each other. So try and see if you know what they are. Okay, and I'll tell you in a few seconds. So what are they? Write down the names of all the shapes that fit his description. There's only two I can think of. Four-sided shape, so it's a quadrilateral, with at least one pair of adjacent sides equal. So the sides next to each other are equal. So what would that be called? So they are now called a square or a rhombus. A square or a rhombus. Why? Because they are next to each other and are equal. So remember, if you have a rectangle next to, or you have a rectangle, the sides next to each other won't be equal. Okay. So you'll have the bottom side is 5, and the side, the one on the upper side is called, it's weird to say without actually showing it to you now, would actually be called a What am I saying? Sorry, I got interrupted while I was busy talking. Anyways, so if you have a side going here, that side there will be the same as that side going there. Whereas in a rectangle it will be different. So that side there will be different to that side. Anyways, moving on. Okay, so we did that question. And then I think we didn't do... There was another question. Oh, we did this one. But I didn't tell them to draw the lips. So I just said to them, for 7, I said write down the letters of all the shape or shapes that are congruent to shape B. And then the last one, write down the letters of all the shape or shapes that are similar to shape B. Okay, so write that down. So you can pause and then write it down. Alright, so now we are going into that shape B. And we're first going to do all the congruent ones. So technically, there's only one shape in here that is congruent to shape B. Because we've got 3 blocks here and 3 blocks there. So the only shape that is with 3 blocks and 3 blocks is H. So H and B are actually the same. So that would be the congruent ones. Alright? But then you've got other shapes that are actually also congruent to shape H. They've just actually enlarged it or made it smaller. And they've turned it. So because they're turning it, I'm then also going to say that it's congruent. So what I want you to do is put H as your answer, and then in brackets I want you to put the other shapes that are actually turned. So it would be A. Well, C is not really. Let's just use C. Let's use A, D, and maybe C, because it's actually, it is turned, so I'm actually just going to use that. So A, C, D, those are your shapes that are in brackets congruent. So they're not actually congruent, but they're kind of congruent. And then we've got the similar shapes. So the similar shapes are all the other ones basically that are now not congruent. So you see this one is smaller than B, so A is also technically similar. So it's similar, 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 similar. Okay, so it's basically A, C, D, E, F, G. Alright, so those are your answers for that. And then I think we didn't do anything else after that. So that was what we did on Friday, and then you should be all sorted. But yeah, otherwise I hope you have a great week. And I'll let you guys know whenever I get the chance for anything that you've missed and all that kind of stuff. I'll also put this on Class Dojo for you, so that you know what things to look for in Siyavula. It's really great if you want to look at maths. So if you're struggling with certain sections, I suggest you go and you do that. They don't just have maths, they've also got natural science, all those kinds of things. They've also got a different type of maths textbook as well. So that's not on Siyavula, this is actually MST or something. It's not the same maths textbook. So you've got the Siyavula, and then it goes all the way up to grade 12, so it's actually really nice. Especially, so like if you want physics, here's natural science for grade 7, grade 8, grade 9, all those kinds of things. Technology, remember we don't have natural science and technology, we just have technology, but that is in here somewhere, I saw it. Yeah. Okay, so here's Siyavula textbooks, so there's grade 7 and there's grade 7, so that's Siyavula. But then if you look in here, it's got a learner's book, but I don't think it is Siyavula, I think it's MST or M something. Anyways, also pretty good though, so you can check that out. So if you're struggling with material, separating mixtures, or struggled with that, so you can always go check that out. We haven't done any natural science, we kind of like spoke about it in school, but we didn't actually start with anything like proper in revision yet. So yeah, it was mainly a question answer, it's a chilled session. But please don't just carry on with what you think you should do. Curriculum has changed a bit, especially in geography and stuff. Yeah, so we covered most of what we need to do for geography at the moment, and then we will start the new work as soon as we've done all the revision for lockdown. Alright, otherwise, I hope you have a great week further. Enjoy it, stay warm, and I miss you guys, I really do. Hopefully we'll get to do like a live session or something at some point, but we're trying to figure all that stuff out at the moment. Anywho, okay, enjoy it, have fun, and you can always message me if you're stuck with something, so go ahead, I don't mind. I might take a while to respond, but you can try. Anyway, alright, bye guys.